Hypothesis testing. In this video, we're going to look at basic principles of hypothesis testing. The purpose of hypothesis test is to determine how plausible a starting assumption is. We call this starting assumption null hypothesis. So let's just look at an example to begin this lesson so we can get an idea what it is that we're doing. Suppose an individual is charged with crime. The individual would face trial by jury where the individual is presumed innocent. Evidence is present at trial if evidence strongly indicates the defendant is guilty. Then the jury abandons the assumption of innocence and finds defendant guilty. So in this scenario, we have beginning assumption, which called a null hypothesis, is defendant is innocent. And if evidence supports otherwise, we assume the defendant is still innocent. But if the evidence supports the defendant is guilty, we have another alternative hypothesis called, um, in this case, we defendant is guilty. So in this section, hypothesis testing, we're going to look at problems like this. How do we form a hypothesis statement, and how we test it, and how we make conclusion. So let's look at more definitions, specific definition. Hypothesis is a statement regarding characteristics of a one or more population. So it's a statement about population. And what we're doing using statistical ideas is we're testing hypothesis. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding characteristics of one or more population. So we want to make a conclusion about population using sample evidence and probability. Okay, so there's a basic 3 steps for hypothesis testing. First, we make a statement regarding the nature of the population, given in the problem what it is we want to test. Okay, that's the first step. And second, we collect evidence, which is sample data, to test the statement. So this is where we need to do some calculation and find the probability. Calculation. Formulas, using numbers and stuff. Third step is analyze the data to assess the plausibility of statement. This is where we make the conclusion. So in this video, we're actually going to focus on how to make a statement and how to make a conclusion first. And then we learn how to do the detailed calculation. But first, we want to comprehend the basic structure of hypothesis testing. So we later use this language, but let's have a look at precise definition of null hypothesis and alternative hypothesis. Null hypothesis, we use this notation, H naught, that's how we say it, H naught, is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference. And this is assumed true until evidence indicates otherwise. Just like the individual is innocent until proven guilty. The similar idea here. We assume null hypothesis is true unless indicates otherwise. Alternative hypothesis is known as H1. We write H1, and sometimes we also write HA. A stands for alternative, so both means the same thing, H1 or HA, is a statement that we're trying to find the evidence to support. And we'll look at some example how to form this, but just know that we have 2 statements when we're doing hypothesis testing. And there are 3 types of tests, 3 ways to set up the null and alternative hypothesis. Okay. So first one is hypothesis versus not equal to hypothesis. So parameter we're dealing with, either mean, proportion, or statistics, is not equal to some value. So that's how we have 2-tail. So using the normal distribution table or also T distribution, we're finding this probability. That's why it's 2-tail, not equal. Not equal means the value has to be either greater or less. That's why it's 2-tail. Would be left tail if a parameter is less than some value. Less than, which is right here. And right tail test is greater than some value. So in this case, we're finding probability of this. So just know that depending on the problem, we have three types of tests. And let's review. We're working with the parameters. Oops. Parameters here, right? Parameters, parameters, parameters. Parameters is a value from population. So what are some examples parameters we saw? Population mean, population uh, standard deviation, or population proportion. So those are the values that we want to test. So let's practice setting up null and alternative hypothesis statements. We're just practicing setting the statements. So according to the American Time Use Survey, the mean, that means we're dealing with the population mean. So write the mu symbol. Mean amount of time employed male Americans spend working weekends is 5.46 hours. A researcher wonders if male employed part-time work more hours on average on weekends. Okay. So always when we set the statements, we have two, H naught or and H1. Again, we can also write HA. Both are equally used. HA also means alternative hypothesis. And here we're dealing with the mean. So write mu. Okay. And let's highlight this part. The employer wonders if the male employee part-time work more hours, more than this number. So this is the alternative hypothesis. So we wonder if it's greater than 5.46. Null hypothesis is actually unchanged, no effect. And we can also think null hypothesis opposite of alternative hypothesis. So in this case, mu is 5.46 hours. So unchanged. For null hypothesis, though, we can also write opposite of this, opposite of null alternative hypothesis. So since it says mu is greater than 5.46, null hypothesis also could be less than equal to 5.46. Either way we write for null hypothesis, the conclusion does not change when we find the conclusion later. So from here, we're testing, we're to do some calculation and find the conclusion, right? But we're just looking at the first part of hypothesis testing. So here it also asks, problem also asks to find the if it's left tail, two tail, left tail, right tail. In order to determine that, we look at the alternative hypothesis. Here it's saying that mu is greater than 5.46, greater. Therefore, it's right tail test. Right tail test. Okay, so let's look at second example. Harris Interactive reports that 55% of adult Americans aged 18 over prefer purchasing name brand coffee over generic brands. Marketing manager Starbucks wonders if the percentage of seniors who prefer name brand coffee differs from all adult Americans. Here we're dealing with percentage of some sort. That's a proportion, P. So when we set a hypothesis statements, we need to use P as a variable, well, as a parameter, P. And the manager wonders if it differ from 55%. So for alternative hypothesis, different from 0.55. But in that case, then null hypothesis, which is no change, would be 0.55. So unless it's proven otherwise, we assume that seniors also prefer same percentage. 55% of seniors also prefers brand coffee. So in this case, opposite of this is also equal. So there's no other way to write null hypothesis. This is the only way for two-tailed test. And looking at here, it's not equal to, right? Alternative hypothesis is not equal to. That means we have two-tailed test. This recognizing two-tail test, left tail, right tail is important later on when we calculate to find the probability. So make sure you build a habit of writing these. So let's look at part C. Using an old manufactured process, the standard deviation of amount of wine put in the bottle was 0.23 ounces. With a new equipment, the quality manager believes the standard deviation has decreased. Here we're dealing with standard deviation. So when we form the hypothesis statements, we have to use standard deviation as a parameter. And the control manager believes standard deviation decreased. That means less than 0.23, less than 0.23. And new hypothesis is something we assume otherwise, which is 0.23. We can also write opposite. You need to be aware of both of these. Okay? New hypothesis is something we believe it's true unless it's proven otherwise. We can also think it's no effect. We can also think it's opposite of alternative hypothesis. So this would be opposite. This is less than 0.23, so opposite is greater or equal to 0.23. And in this case, look at here, since this parameter is less than a number, it's a left tail test. Left tail test. Okay, let's look at part D. I actually like you to pause the video and try this problem on your own. When you come back, I'll go over it. Pause the video now. Okay, so this problem, the Center for Disease Control Prevention says 19.6%. That already tells you we're dealing with proportion of children aged 6 to 11 years over are overweight. A school nurse thinks the percentage, 6 to 11-year-old overweight, is actually higher in her school district, right? So she's hypothesizing. She's making hypothesis statement, right? So you can always build the habit of writing these. We're dealing with proportions, right? P. She believes, alternatively, it's greater than the given percentage. But new hypothesis is equal to. Or we can also write opposite, less than equal to 0.196. And we look at the alternative hypothesis to determine if it's left tail, right tail, or two tail. Since proportion is greater than, they're claiming is greater than, this has to be right tail test. So this is how we make the statements, hypothesis statements. Once we form the statements, we do some analysis, do some calculation, and based on that calculation, we make conclusion. But for hypothesis testing, we're going to first learn how to conclude now, because that makes more sense in terms of understanding what it is we're doing. So there's a basic 4 outcomes of hypothesis statements. So remember, we have 2 statements, new, H naught, and H1, alternative hypothesis statements. Right? So we have 4 outcomes: is we reject new hypothesis. We reject new hypothesis. When alternative hypothesis is true, then decision will be correct. So you can think this is kind of like, let me erase this part. Think like this. We have a new hypothesis and alternative hypothesis. So if we reject this, when this is actually true, then our conclusion is correct. So we reject alternative hypothesis, then this means this is okay. This is true. And that decision is correct. If we do not reject H naught, that means we don't throw this away. We do not reject H naught when this is actually true. When H naught is true, we don't reject it. Then this decision is correct. So these are the 2 correct conclusions. But it is possible to make incorrect decisions. So that's when we reject new hypothesis, we reject this H naught. When actually this was actually indeed it was true, which we want to avoid this, and that error is called type 1 error. And another way is we don't reject this H naught when alternative is actually true, and they'll be incorrect. And that type of error is called type 2 error. Okay, so let's look at this chart to just summarize this. Again, the way is that we think about is with H naught versus H1. But the way we make conclusion and hypothesis statements, we either reject or don't reject H naught. So if you reject this, right? If you reject this, that means we are taking this as the conclusion. And if that's true, then we have a correct conclusion. If you reject this. If you don't reject H naught, that means we're taking H naught as the conclusion. And that's a correct conclusion. But it is possible that, okay, let's say I don't reject H naught. I don't reject it. But in fact, actually H1 was true. Then we get type 2 error. I rejected H naught. But in fact, H1 is actually true. But then we get type 1 error. So this is something we want to avoid. We want to avoid type 1, type 2 error. Especially actually type 1. Type 2 error is actually very complicated to calculate in reality relative to type 1 error. Okay. So in our class, we're going to focus more on type 1 error, how to avoid it. But moreover, our main focus is on how to state the correct conclusion, given after we know how given a conclusion. Okay. So let's look at example of type 1, type 2 error in scenario. How would it look like? So explain what it means for type 1 error and type 2 error in this situation. This is the example we saw earlier. According to American Time Survey, mean amount of employed. So let me actually just write these two statements. Is that researchers believe the mean hour work on the weekend is actually greater than 5.46 hours. Whereas the new will be equal to 5.46 or less than or equal to 5.46. New hypothesis. So in this case, type 1 error, let me actually write it right here. Type 1 error looks like this. Is that conclusion we make through analysis and calculation is more than 5.46. So conclusion, when I say conclusion is this is the conclusion we make via calculation. Conclusion is actually H1, which is this statement. So think as we can also replace this. Conclusion is H1, but in reality, the mean amount of they worked was less than or equal to 5.6. So it's an error. Type 2 error in that case, then the conclusion is H naught, this statement, but in reality, they're actually greater than 5.46, the mean amount they worked. Okay. So be careful. The conclusion I'm talking about is conclusion we make through a calculation, but in reality, it was actually the other way. That's what we call a type 1, type 2 error. And the probability of making type 1 error is called alpha. So remember, type 1 error is rejecting H naught when in fact H naught is actually true. We don't want this to happen, right? But there's always a probability that this could happen. Beta is the probability of making type 2 error. This is not rejecting H naught when actually in fact H1 is true. Okay. So in hypothesis testing, the probability of making type 1 error, alpha, is chosen by the researcher before sample data is collected. And this is called the level of significance. The level of significance. That's how we call this number. So this is important because in a problem, level of significance will be given. And we compare this value with the probability we get to make the conclusion. So that's what alpha is. So we'll be seeing the alpha value a lot, and it'll be given in the problems. Okay. So we type 1, type 2 error are what we call incorrect conclusions. Incorrect. So let's look at how correct conclusion will look like in a problem. Stating conclusion to hypothesis test. So important thing is, again, let's write H naught and H1. And we always write the conclusion around H naught. Either we reject this, that means we take H1 as the conclusion. If we don't reject H naught, that means we take H naught as the conclusion. That's the basic idea. But we do have to be careful of the language you use because it involves in probability. We never quote unquote accept. We don't actually use this verb here because without having access to entire population, we don't know the exact value of a parameter set in the new hypothesis. Okay, so that's why we use the language of we do not reject the new hypothesis. Instead of saying that we accept new hypothesis, we do not reject it. And again, this is similar to the core system, the innocent guilty example we saw earlier. We usually say, we never say defendant is innocent, but we rather say defendant is not guilty. Based on the evidence, we can say that the defendant is not guilty. Okay? So the language we use is very important because we don't want to sound more than what we know in general, right? Especially in these problems. So let's look at an example that I wrote here. According to study in March 2006, mean length, we're dealing with the mean length, a phone call on a cellular telephone was 3.25 minutes. A researcher believes, alternatively, believes the mean length of phone calls decreased since then. So suppose the evidence indicates the new hypothesis should be rejected. Again, this is something we're going to learn later, how to determine ourselves that is rejected or not rejected. That's through some kind of calculation with formulas. Okay. But suppose it should be rejected. The wording of conclusion to be followed. So let me write actually down the statements first. Alternative is that mean is less than 3.25 because researcher believes that it is actually decreased. But the new hypothesis is equal to 3.25 or greater than equal to 3.25. Okay. So if new is rejected, this is rejected. That means we take less than 3.25 alternative hypothesis as a conclusion. But the way we say is like this. The statement alternative hypothesis, the mean length code is less than 3.25. Since the new hypothesis rejected, this is rejected, then there is sufficient evidence to conclude that the mean length of a phone call is less than 3.25 minutes. So this blue statement, this is actually just writing the H1 alternative hypothesis in words. So we always use the language in line of there is sufficient evidence to, there is not sufficient evidence to. We don't say absolutely we accept or not accept. That's not the language you use in hypothesis testing. Okay. Since we rejected H naught, there is sufficient evidence to conclude H1. That's essentially what this is. How about if it's opposite then? Let's say we did the calculation and scientific evidence indicates that new hypothesis should not be rejected, not rejected. So if H1, H naught again, this should not be rejected. Then, the way we state the conclusion, since it's not rejected, there is insufficient or not sufficient evidence to conclude that alternative hypothesis is true. In other words, sample evidence is consistent with the mean length code equaling 3.25, or it also could be greater than 3.25. So again, the idea is always H naught versus H1, but the important thing is we either reject or don't reject H naught. And in conclusion, when we actually say the words, we only use alternative hypothesis, either enough evidence to support H1 or not enough evidence to support H1. So let's look at some practice. Okay. Again, let me remind you, we are practicing how to set up the hypothesis statements and then how to make conclusion. The mid step will come later because those are just practicing a lot of procedural formulas, recognizing the problem. But we're trying to look at a big picture of what hypothesis testing is. Okay. So we already looked at this example, but just do one more time. According to the American Time Use Survey, mean amount of time employed male American working weekend is 5.46 hours. Okay, we saw this example. A researcher wonders if male employed part-time work more hours on average. So again, we always let's write both statements. Researcher believes that the mean length is more hours greater than 5.46. So that alone tells us this is right tail test. I know it didn't ask us here, but it's a good habit to always indicate right, left, or two tail. And null hypothesis then is equal to 5.46 or oops, less than equal to 5.46. Okay, so let's write the conclusion. In this problem, it says null hypothesis is rejected. We reject H naught. We reject this. If you reject means since this is rejected, there is enough evidence to support the alternative. So let me write the answer. Reject H naught. Again, problem tells us to reject H naught just to practice writing conclusion, right? We'll learn how to calculate, how to determine we should reject or not reject on our own later. So let's say we reject H naught. That means the, there's sufficient evidence to support that the mean time spent working is greater than 5.46 hours. So this part right here, this part is just writing H naught in words. And that's always the case for conclusion. So only part will it change. If we reject H naught, there is sufficient evidence. If we do not reject H naught, there is not sufficient evidence. All other wording will be the same. So let me demonstrate in the part B. In part B, it says not rejected, do not reject, or fail to reject. Do not reject. That means between H1 and H naught and H1, we don't reject H naught. That means there is not sufficient. There's not sufficient. Let me actually use a different color. Not sufficient evidence to support that the mean time spent working is greater than 5.46 hours. Right. So again, this part is same. This part is just writing H naught in words. Mean is greater than 5.46. What's the mean here? Mean time spent working in weekend. So do not reject means not sufficient. Reject means sufficient. That's always the pattern we'll see in conclusion. Okay, but we need to practice writing words in the context of each problem. So the mean caffeine content per cup of regular coffee served at a certain coffee shop is supposed to be 100 milligrams. A test is made. So here we're just practicing writing the conclusion. The mean equals 100, mean not equal to 100. So this is two-tailed test. Two-tailed. After calculation, the new hypothesis is rejected. So they're telling us the conclusion. It should be rejected. Again, this is on future lessons. We'll look at how to determine reject, not reject in future lessons. Okay. So it says H not reject. State the conclusion. Okay. So let me write this one. Reject H not. That means there is sufficient evidence or you can also write enough evidence. There is sufficient enough there is sufficient evidence to support that the mean caffeine content is not 100 milligram or not equal to 100 milligram. So let me highlight this again. Reject means there is sufficient. And this portion here, mean caffeine not equal to 100 gram, we're just literally writing this in words, the alternative hypothesis in words. Okay. let me just emphasize again, we do not say absolutely in these cases because we're dealing with a probability. That's what we need to say. There is sufficient evidence, there's not sufficient evidence. We do not absolutely say that, oh, the mean caffeine is not 100 milligram for sure. Okay. Even if you don't add the for sure part, just even saying the mean caffeine is not 100 milligrams sounds more absolute than we could figure out. That's why we need to add this. There is sufficient, not sufficient. There is enough or not enough evidence. So, second example. Why don't you pause the video and try this on your own? It's important you to actually practice writing this down. So pause the video now. Okay, so let me go. The veterinarian claims the mean, again, we're dealing with the mean. That's why we use the symbol mu. They provided here. Weight of adult German Shepherd dog is 75 pounds. A test is made of no hypothesis equals 75, alternatives not 75. So this is also a two-tail test. I know it doesn't ask us to determine, two-tail, left tail, right tail, but it's a good habit to build it up because eventually, for a full problem, we need to determine this to essentially find the calculation, essentially to determine if it's reject, not reject later on. So it's a good habit. After calculation, the new hypothesis is not rejected. Do not reject. Stay to appropriate conclusion. So do not reject. Do not reject means there is not sufficient evidence. There sufficient evidence to support that the weight is not equal to 75. So do not reject, there is not sufficient evidence. Not sufficient evidence. And this part, the weight is not equal to 75, it's just writing or turning the hypothesis in words. This is always same pattern, but you just need to practice writing in the context of these problems. So look at this example. Why don't you try this on your own also? Pause the video and try. Okay, so let me go over it. Says a sales manager believes the mean number, or we're doing the mean again, of days per year in his company sales representative spending traveling is less than 50. So alternative hypothesis mean is less than 50. New hypothesis, I mean, they give us here, but you need to also write this on your own if it's not given, as we did earlier in examples. Again, you can write either one of these and you will not affect the conclusion. After some calculation, new hypothesis is not rejected. Stay to conclusion. Not rejected. So do not reject. Or sometimes we use the word fail to reject. It implies the same thing, fail to reject. It means there is not sufficient evidence to conclude, so fail to reject, that the mean days per year sales reps spend traveling is less than 50 hours. Or that doesn't say hours, but let's assume it's 50, although it doesn't say hours. So again, this part is just alternative hypothesis in words. So fail to reject, there's not sufficient evidence. So these are the ways we conclude. And of course, all these, this last one example we did are correct conclusions. How to make correct conclusions. So as I said a few times, we will learn how to calculate so we can determine if the null should be rejected or not rejected in later lessons. So to summarize the video, what we looked at in this video is that here's the main three steps. We looked at how to make statements, right? H naught and H1, given problem. We also looked at how to make essentially conclusion, analyze the data to make the final statement. Enough, not enough evidence, right? So this middle part is what we're going to look at: how to collect evidence to test the statements, and also analyzing the data. Right? So this calculation part will come later. But just note that what we did in this video, we looked at the overview of hypothesis testing. We learned how to set up the statements and how to make the conclusion once we determine if we're rejected or not rejected. So that's the big picture of what hypothesis testing is. We can determine if the alternative hypothesis we make can be supported or not supported. Like in this example, not equal to 100 milligram, right? That's the alternative hypothesis, right? Or let's look at another example. Like in this example, the school district nurse believes that the overweight in her school district is actually higher. She believes it's higher. Or let's test it using sample data. Okay, so although we didn't look at conclusion for this problem, these are the kind of problem we can potentially find a conclusion. Or is there enough evidence to support her belief or not? Okay, so we looked at the big picture of what hypothesis testing is in this video, following these 3 steps. So later, in a future videos, we'll look at how to calculate so that we can actually determine ourselves should we reject or not reject H naught, new hypothesis.